I'm really excited to present at Virus Bulletin Conference for fifth straight year, and it's always great to be part of this amazing community. In this presentation, I'm going to cover some of the different pivoting methods to track, monitor, and attribute threat actors. When I started my job as a threat intel analyst, I struggled finding resources that helped me to track and attribute APTs. So I thought putting everything together and presenting as a talk would be helpful for threat intel researchers. Okay, first, a little bit about me. I'm Hossein Jazi, and I'm Senior Threat Intelligence Specialist at Fortinet. You might know me from Twitter, which I used to be very active, but not that much these days. My passion and background is on tracking, monitoring, and attributing cyber threat actors, and especially nation-states ones. And as part of my APT research, I perform threat hunting, malware reverse engineering, infrastructure analysis. I'm also a big fan of blogging, so whenever I get time, I publish something on my findings, and I also present at cybersecurity conferences. Recently, I became interested in cyber criminal investigations, and right now I'm working on a couple of projects in which we track cyber criminals. Okay, I'd like to point out a couple of things before I begin my talk. And first off, there are several tracking methods, and different companies use different methods for tracking, especially some companies are using incident response and forensic, which provides a clear picture over the attacks and victims for attribution or tracking also. The aim of this talk is just, my goal here is not to focus on incident response and forensic, as many threat intel teams, especially the small teams, do not have access to such a data. So my goal here is to provide some of the pivoting techniques that you can use to track and attribute APTs. Also, mature threat intel teams, usually they have some in-house tool available for themselves and usually use those tools as base foundation for their trackings. Here, I just want to provide pivoting techniques for smaller and less mature threat intel teams and the teams that they want to start tracking and attributing APTs. So this is the overview of the different pivoting techniques that I'm going to cover in this presentation. And I categorize them into four main categories: file-based, TTP-based, ML-based, and network-based. File-based techniques refer to set of techniques in which we use a static feature of tool set used by threat actor to track activities to a specific threat actor. In TTP-based methods, we mainly focus on TTPs and a specific set of techniques or behaviors that are used by threat actors to track their activities. And in ML AI-based, I'm not going to cover really in this presentation, but the focus of ML AI techniques are using different machine learning models for tracking, especially for attribution, code similarity analysis, and things like that. And the last category is network-based techniques, in which we focus on tracking APTs based on the infrastructure they are using. So if they are using a specific IP and domain, we can start tracking them using those features. So in the rest of the talk, I'll go over each of these techniques, and I'll provide an example of how I use this technique to track a specific threat actor. The first category that I'm going to cover is file-based tracking. File-based tracking refers to using different artifacts extracted from a static analysis of tool sets as a pivot to track new activities associated with threat actors. And one of the simplest and still useful feature is a string. So when there are like strings embedded within the binary, and still you can use them to track similarities associated or activities associated with threat actors. An example of in this case, it was on 2020 when I was analyzing Dakal's rat, also known as Mata framework, associated with Lazarus APT. And I noticed their Linux and Windows versions, most of the samples were using a specific strings, which were certificate name and private key. And using those two specific strings, I was able to identify the Mac variants of this framework. So this is a good example that shows by using like a specific string, you would be able to see evaluation of the threat actor. In this case, I was the first that identified that Dakal started to use Mac variants, target Mac systems. And there are several static indicators are available for tracking. And aside from strings, there are other features like import, export names that can be used for tracking, especially imp hash also can be used to track malware families. So imp hash is a hash that is generated from import address table of a binary. And by using this hash, you can find similar samples associated with a threat actor. A simple example here is that the local potato exploit that used by Fin11 use the same imp hash, so you can use all the different variants of exploit that have been used in this attack. Okay, so one of the most useful and I would say most accurate method for tracking and pivoting malware samples associated with APTs is code similarity. So threat actor often use a specific part of code that can help us to track their activities. And I should mention that the part of code that I'm talking about here is mostly used generic part to track APTs, not the specific part of code that researchers usually use to track a specific or find a specific variants of malware samples. So example of these kind of code parts are, for example, a specific API hashing key or a specific encryption algorithm, or if they use a specific, like for example, persistence mechanism. And a good example of this case is when we were analyzing an activity associated with Lazarus APT, and we noticed that the sample that we were analyzing used a specific decoder. And by using that decoder, we were able to get more samples associated with Lazarus APT, not specific to that campaign. So using that code similarity, it helped us to attribute and also track activities associated to this specific campaign. I think most of you know about VirusTotalDiff and VTGrep. So VirusTotalDiff is a great feature developed by VirusTotal to find similarities between malware samples. And this feature is kind of similar to code similarity analysis. So if you don't have a strong reversing skills and still you want to find the similarity between samples, you can use VTDiff to find similarity between samples, and then use VTGrep or VTRetroHunt to find similar sample associated to that specific APT. So in this case, it was the time that I found APT site copy has started using the Linux variant in its campaigns. And then at the time, I had only 2 samples associated to that campaign. Using those 2 samples, I use VTDiff to find the similarity between the samples, and then use VTGrep to find more samples associated to this campaign. So as you can see, I found 9 more samples associated to this campaign, some of which have been used like I guess, 2 months, 3 months after the campaign has initiated. Another good example of VTTIF and content search is Ersbactia. Ersbactia is a APT that I guess recently discovered by Trend Micro team, and this is a Chinese APT that is using MSC file to target their victims. And again, using VTTIF and VT Retro Hunt, I was able to get all the DLLs that used in this campaign, and this is really serves as a good rule for tracking future campaigns associated to this threat actor. Okay. Another pivoting method that can be used to track APTs and identify malware families is or malware variants is fuzzy hashing. And there are several methods to calculate fuzzy hashing, such as SSTIP, STHash, and TLSH. SSTIP, I think, is the oldest one, and initially was introduced to find the similarity between spam campaigns. But the problem with SSTIP is that when you use on the binaries, it mostly generates a lot of false positives. So you have to spend a significant amount of time trying to filter out false positives. STHash and TLSH are more reliable for tracking, and I personally primarily use TLSH, which I find it really robust. TLSH is a method introduced by Trend Micro and is really robust against minor changes and can be used to cluster malware samples and identify new malware variants. It also can be used to find similarity between different file types, not only binaries. And a good example of this case is that we got an HTML file a couple of months ago, and the HTML file was connecting to an IP. That IP was tagged as a specific rat, but we really weren't sure that that HTML file is associated to that rat. And we weren't able to get the final payload at the time. So we used TLSH, and we were able to get 21 more samples that had similarity with this HTML file. And what we noticed is that we find one HTML file that used a couple of months before this campaign, and it was tagged as gamma red zone. And then we did our search and analysis, and we noticed, this one is gamma red zone too. So in this case, TLSH is really helped us to associate the campaign to a specific threat actor and also find more samples associated to this threat actor. Another example of fuzzy hashing is when we discovered Cytomobacter. Cytomobacter was used by APT34 oil rig, and again, we got the initial email and then the document. And again, we needed more confidence on attribution and tracking, and using TLSH, we got more samples, more malicious document. At the time, they were using malicious document associated to that threat actor. So this helped us and gave us a higher degree of confidence in attribution, and also gave us idea about the tracking of this threat actor. Signatures play an important role in malware and APT tracking, and you can develop rules based on static features of toolset, or also sometimes dynamic artifact to help you track APTs. And one of the most common rules that widely used by researchers is YARA rules. So you can use different values in YARA rules to track APTs. For example, you can use strings, you can use a specific code segment or a specific part of header value to track malware sample. This is a simple example of YARA rule in which you can use to a specific string to track SFX file associated with Torla APT. And one thing that is not like all the time accurate, but I find it sometimes is very useful is like AV signatures. For those who that are using VirusTotal, some of AVs are really reliable on tagging samples. And this is a good example of kind of AV signatures for tracking. This is ESET is doing really good job on tracking North Korean APTs and especially Buertel malware. And at the time, there were very low detection rate on those samples. But if you know how to use those rules or AV signature, you would be able to track all the Buertel samples associated to Lazarus APT. Another useful pivoting technique is code signing certificate. Code signing certificate are digital certificate that used to sign malware, ensuring the integrity and authenticity of a software. However, attacker can steal those certificates and sign the malware and make them look legitimate. This gives us an opportunity to start tracking threat actors' activity. An example of this case is when we discovered WinTapix driver. This is a driver that primarily used by Iranian threat actors, Leafminer, to target Middle East. And at the time we had one sample of driver, and we noticed they were using two specific certificates to sign their malware. And we thought that we can use those certificates to look for similar samples. So what we did, we started to look at certificate and find similar samples, but the problem was that these certificates have been used by several other threat actors too. So we had to filter out our search to be able to find samples that are associated to this specific threat actor. So what we did in our search query, we looked for the samples that have signed by these two certificates, and they are drivers, and they are submitted from a specific region because they were part of a targeted attack. At the time, it was Saudi Arabia. The last pivoting technique that can be used to track APTs in file-based category is metadata. Metadata is information embedded within the malware files that can help track and attribute malware samples. Metadata is categorized into two categories: file metadata and compiler metadata. And file metadata refer to information related to timestamps and file properties. And while compiler metadata includes information about compiler, such as rich headers and PDB paths. Rich headers contains information such as compiler version, link library, and build environment details, and they are useful to identify malware samples with similar build environments, and also link new samples to non-threat actors based on their shared development practice. And you can use rich header hash to track APTs, and this is a rule developed by security researchers to track Torla APT based on their rich header hash. PDB path is another useful piece of metadata that stores debugging information. It can reveal the name of functions, name of variables, and helping to better understand the malware behavior and structure, as well as providing more detailed information about the debug environment. One specific thing that the PDB path provides is that it shows where exactly the file was compiled. So some of the companies that have access to those like machines and like have great visibility, if they found the PDB path, they know where the machine is. So they can go to the machine, get all the files over there, and track the sample. So track the APT. So, but mostly within the researchers and like small teams that have limited visibility, they are using like specific things like PTB paths, PTB strings, that contains like information about the source code file, directory structure, username, and project's name. So you can use them to track APT. So this is an example here in which APT29 use this PDB path string, and you can get related samples by using this PDB path. Okay, sorry. Sip of water. The second category is TTP-based tracking, and in which we focus tracking attributing threat actor using their behaviors and more specifically their TTPs. I'm sure most of you are familiar with MITRE ATT&CK framework, and what we notice is that like APTs tend to use a specific set of techniques in their campaign. So if you are analyzing campaign, running a sample in sandbox, get the full picture, full behavior, you can map out into the MITRE, and if you know details about the specific APT and see specific TTPs are used by that threat actor, for example, I don't know, DLL side loading is used by that campaign, is a good sign that it could be a Chinese threat actor. Still, you have to use more indicators, add more information to that. And one thing I forgot to mention when I was talking about the different categories, it's important that if you want to have effective tracking method, you have to consider all aspects of that APT. So you have to have file-based, TTP-based, and network-based in place so you would be able to effectively track that specific APT. Also, in the behavior, if you know APT is using a specific behavior, you can use for tracking. For example, this was an example at the time. Lazarus APT was using pkelia.exe to run some specific commands, and using this specific command, we were able to track all the activities used by this subgroup of Lazarus. Infrastructure tracking is one of the most important categories for tracking APTs, where we use pivoting techniques on the network indicators utilized by threat actor to monitor their activities and uncover the new infrastructure before it's even be used by threat actor. In infrastructure tracking, we monitor and analyze network component of APT such as IP address, domains, servers, and communication channel. And we are trying to find patterns within their infrastructure to link attack to some threat actors. So several key techniques is used for tracking for infrastructure tracking, such as passive DNS analysis, SSL TLS certificate analysis, who is data analysis, network traffic analysis, and fingerprinting techniques. I'll cover some of them in the next couple of slides. But tracking infrastructure comes with its challenges too. So you need to continuously monitor network and keep your intelligence updated, because threat actors are changing their infrastructure. So it's important to keep updated with those changes. Also, sometimes it's really hard to link different infrastructure together to each other. So you have to be careful about how you connect and link different things together. And as I said, threat actors often change their infrastructure to avoid getting detected. So you have to be careful about these changes. Some threat actors reuse infrastructure due to resource constraint most of the time, and this infrastructure reuse help us to identify new samples associated with a same campaign or a new campaign. And I think most of you now know that VirusTotal introduced a new feature called NetHunt, and it's useful to find the samples that are using the infrastructure. So here is an example of VT Hunt that we developed in our team to try to track malware samples, beavertail malware sample used by Lazarus APT that use this same infrastructure. And interestingly, there were a lot of samples, like we got a lot of samples that reuse this infrastructure. Another interesting example of infrastructure use was with APT bidder, and I think at the time it was May this year that we find a domain used by APT bidder, and we created a VT net hunt, and we started to monitor the samples that we get from out of this rule. And in July 2024, we got a couple of samples that reused that same domain. What was interesting about that discovery was that it was the first time that we noticed that APT bidder has started to use Trojanized versions of SoftEater and AnyDesk. Passive DNS is a system that stores and records historical data, historical DNS data, and such as IP address that a domain used in the past. And passive DNS data can really help us identify and connect non-APT activities. An example of this is APT 42, in which they started to use a domain in January 2022, and it was resolved to that specific IP, and then the IP has changed over the time. And after a couple of months, if you track back the activity and go to use passive DNS and see the domain, you would see the IP, you would see a couple of more domains registered on that are resolving to that domain. So using that passive DNS data and domains that resolving to that IP, you can uncover more infrastructure associated with APT 42. And another example of using passive DNS data was when we were analyzing, again, I'm a big fan of North Korean APTs, so you would see a lot of North Korean examples here. So yeah, it was a time that I was analyzing Lazarus APT group's activities, and using passive DNS and pivoting from the IPs, I was able to get more LNK files and also more kind of uncover more infrastructure associated with this threat actor. This really helped me uncover more infrastructure and additional samples linked to this campaign. IP address metadata also can provide useful information to help track threat actor information such as ASNs, hosting providers, CIDR blocks, server types, running services, and ports are the information that you can use for tracking. And usually you need to use a combination of these kind of things together, these metadata together, to have reliable tracking. For example, some of threat actors are known to use a specific ASN hosting provider and running a specific service on their IPs. In addition to metadata within the IP address, we can leverage HTTP services for tracking, and most important methods for these three, for tracking HTTP services, are response header, response content, and certificates. And I'll cover these three in the next couple of slides. SSL TLS certificate are digital certificate that authenticate a website and identity and enable encrypted communications between a web server and a browser. This ensures that sensitive information such as credit card data and other information transmitted securely and prevent unauthorized access. SSL TLS certificate and their fingerprints are really useful for tracking infrastructure associated with a threat actor. An SSL fingerprint is a unique identifier for a TLS SSL certificate, which is generated by creating a hash of a certain values in SSL certificate handshake data. So when a certificate is issued, data such as public key, signature, and different information goes through a hashing algorithm to generate a unique fingerprint. So there are several fingerprinting techniques are available, such as JA3, JA3 plus, JA4, and JRM. JA3 and JA3 plus focus on identifying malicious clients, and they are using some specific information to generate a fingerprint. In JA3, they are using information such as cipher suites, SSL version, and extension to generate the fingerprints. And JA3 Plus is an extension of JA3, and it adds more information to improve the accuracy of the method for detection malicious clients. So it adds like IP address and some other information to the handshake, to the hash generation algorithm. JA4 Plus, and JRM are the methods that focus on fingerprinting the servers. So the methods focusing on identifying malicious servers, and JRM is so the hash that is generated from JA4 just focusing on creating the hash from one handshake, but JRM focus on 10 handshakes, something like that. So it's more accurate when you are trying to track APT infrastructure using JRM. And the certificate contains various values such as common name, subject authority name, issuer, serial number, and validity payload. And usually threat actors are using scripts to configure their servers, or they have a specific habit of using a specific thing. So usually they use certain values within their kind of header certificate. So sometimes you can use specific values within the common name and pivot from common name to get all the infrastructure associated with threat actors. And it's just not using only a specific values. Sometimes they use a specific patterns. So if you know how to write a regex to spot all the common names that generated by that regex, still you would be able to get all the infrastructure that are used by that same threat actor. In this slide, I'm going to discuss how JRM fingerprint can be used to track activities associated with Storm 0558. Storm 0558 is a Chinese threat actor that mainly targeted cloud environments, and they are focusing on Microsoft cloud environment. And they used soft either VPN communications for their command and control communication. So one thing that you can use to track those VPN communication is using their JRM fingerprint. But the problem is that if you only use JRM fingerprint, you would get all the soft either VPN communication, not the ones used by this threat actor. So what was interesting is that Microsoft researchers identified that these VPN communication had unique values. So using two unique values in X509 certificate, you would be able to track infrastructure associated with this Chinese threat actor. And those values were that the X509 certificate had expiration date of 2037. And also the X509 certificate doesn't contain soft either value. An HTTP response header is a set of key value pairs sent by a web server to your browser after you make a request to a website. So these header values provide important information about about the server response, such as the type of content, security setting, and how the browser can handle the information. And there are lots of information in the header that you can use for tracking. For example, you can use server header. For tracking, server header shows the type of web server, if the web server is using Apache or Nginx. And repeated use of the same server can link attacks to a specific threat actor. For example, if a domain using using the same outdated like Apache server, it's a sign that all the infrastructure are associated to same threat actor. Custom headers are also unique values for tracking that can be used for tracking. Usually you can see that some of the threat actors are using a specific custom header. Usually custom header started with X dash something. So usually if you see those custom headers and pivot from those custom header, you would be able to track APTs based on the custom header. Also, cache control expiry are used to kind of manage contents caching, and usually threat actors try to use avoid content caching. So if there is no content caching in the header, it's a sign that the actor is doing some malicious activity. Another information also can be used for tracking, such as content type, cookie, redirection headers. Redirection headers are the URLs that shows the kind of the main malicious URL of when it will be redirected to main malicious URL. So if you look at the specific patterns on those URLs, you would be able to track activities associated with that threat actor. Also, when content encoding, when threat actors try to deliver their malicious content, they define the type of the contents that would be delivered. So usually they use JZip, which is very generic, but sometimes they are specific too. So you can use those information to track threat actor too. And also security headers are another factor that you can use for tracking, especially like X-frame option and strict transport security are used to prevent clickjacking attacks. And you can see if you missing and misconfigured header in this way, you would be able to track activity associated to a specific threat actor. And I'm just gonna provide two examples in this case in next slide. So as I said, usually threat actors, they configure their server in a specific way, and they want to be able to track their victims and understand or know how their victims are trying to have a method to find their victims. So an example here is that Cobalt Strike use custom header name CSBit, and you can use this CSBit to track activity associated with Cobalt Strike. So Cobalt Strike using this CSBit in its beacon implant to identify the C2 communication while blending in legitimate traffic. So if you know this CSBit or spot that CSBit and pivot from that, you would be able to monitor all the Cobalt Strike servers. Another example, interesting example in this case is ETAC hash. ETAC hash is related to content caching header, and if the resources is changed over time, so they send the ETAG and you would be able to see if the resource has been changed in the server. So using ETAG hash value, researchers were able to track all the infrastructure associated to Muddywater APT. The HTTP response content is the actual data or body of response that a web server sends back to your browser after processing a request. And it can be any kind of data depending on what you have requested. It can be an HTML file, an image, or even a video. And there are several key components that can be used for tracking using HTTP response content. You can use HTML hash. You can use CSS pattern, style sheet patterns. You can use JavaScript code, splash page, fav icons, resource URLs, custom error pages, and dynamic contents for tracking threat actors. So this is like a simple example for tracking the response content. And like at the time, there were some servers used by Kimsuki that used these specific strings in their response body. So you can use like this specific string to track some of the infrastructure used by this threat actor. Another interesting example of HTTP response content is with QBot malware, and researcher identified that QBot infrastructure is using a specific HTML title. So using that specific HTML title, you would be able to track infrastructure associated with this threat actor. Aside from passive DNS data, IP metadata analysis, and HTTP services pivoting techniques, net flow traffic analysis would be really helpful for tracking threat actors and mainly for identifying real IP addresses behind services like a VPN, like VPNs that they are using. So also, you can do like some of the like port analysis and other techniques like traffic volume analysis to track a specific malware associated with the threat actor. As an example, if you notice that like there are a specific port being used in some communication, NetFlow communication, maybe it's sign of a specific malicious, a specific malware communication activities. The last tracking method that I want to cover in this presentation is visual artifacts. We usually track threat actors from this different aspect of attack, and primarily we focus on the steps after the compromise. However, sometimes the initial infection vector can be used for tracking, because in the initial infection vector is the time that threat actors are trying to lure victims to open files or try to like convince them to execute something. So usually they are using a specific like images to make their attack look legitimate. So we notice that threat actors are known to reuse icons, logos, and screenshots in their malware campaigns. And using this reuse of like visual artifacts, you would be able to track activities associated with a specific threat actor. An example, I think it was Virus Total that published a detailed blog on this. So if you are interested, you can read that blog. But one example is that like you can track images within the PDF file to identify all the PDF files that are associated with a specific threat actor. And another example that I used like a while ago, I guess it was a time that Lazarus APT was using malicious document. I noticed that they are using a specific icon within their file malicious document. So using icon hash, I was able to find more samples associated with a specific threat actor. And I would say this method, I found it is very useful in several different campaigns. And I was able to get a lot of samples, similar samples or related samples to a specific threat actor campaigns. And here I'm going to a little bit talk about the tools that can be useful for tracking threat actors. And, there are several tools available to help you track and monitor cyber threat actors. For infrastructure tracking, you can use tools like Census, Domain Tools, and Shodan, which are really helpful. Census contains a lot of information about devices, services that are exposed to internet, and you can use several different pivoting factors over there to track threat actors. Domain tools mainly provide information about domain registration, ownership, and things like that. And also Shodan it can help you to search for specific devices and services based on their IP addresses. VirusTotal is a great tool for researchers to track APTs. It gives you visibility over different aspects of campaigns, network, malware. So you would be able, and it has great features like VTDIF, like RetroHunt, URL, so you would be able to track a lot of activities from VirusTotal too. And also, Maltigo is a really great tool for data mining and link analysis, and really helps investigators visualize relationship between various entities such as individuals, organization, and infrastructure. So I would say, like, for the teams that they want to start tracking, some of these tools would be really helpful for them, especially VirusTotal and Census are the two main tools that I use a lot during my day-to-day work. And in the last section, I'm going to talk a little bit about attribution and its connection to tracking. So attribution is the process of identifying the group or nation state behind cyber attacks based on the evidences that we collect from the APT activities. This process is really important for identifying motivations and capabilities of the threat actors. And also it's very useful for the kind of defensive strategy and policy responses for the companies. So attribution methods can be categorized into two main categories: technical indicators and contextual indicators. So in the technical indicators, we try to attribute activities based on the specific kind of technical analysis, such as malware analysis, infrastructure analysis, extract some of the information that we can get from forensic investigation. So we can get a great picture of activities based on the technical side, tool sets, infrastructure. And then the second category, which is really important for attribution, is contextual factor. And it's where we try to kind of analyze the victims, look at the geopolitical situations, and try to understand the motives and behind an APT campaign. So it's really important to be able to connect have these two views together to be able to have a very solid attribution. And what APT tracking is really support attribution on the technical indicator side. So if you do have good tracking in place, I would say you cover the category of technical indicator. So you just need to analyze the geopolitical situation, victimology, to be able to have a precise attribution. And in tracking and attribution, there are always a lot of challenges. And here, some of the challenges that I mentioned, it's not very comprehensive, but still there are challenges that you have to be aware. Like, for example, if you fail to connect information from different sources, such as network logs or threat intel platform, you would miss important link, and it leads to wrong attribution. Also, ignoring the relations between IPs, domains, and malware can lead to have a gap into understanding the attack. Another challenge here is that you have to be sure when you perform attribution. So if you do attribution based on big indicators, usually it would be a wrong attribution. And I did that once, and so you should be careful when you try to attribute that. So you have to have solid indicator to be able to attribute the activities. Also, threat actors are known to use false flag to misdirect you and pretend to be other threat actors. So you should be aware of those false flags. So it's important to, as I said, track threat actors from different aspects. So if you see false flags, for example, I don't know if a malware there are like comments in Chinese language, it's not the sign of like Chinese threat actor. Another challenge is that, like, as I said, you have to consider the bigger picture. You have to consider geopolitical organization reasons behind the attack. And if you ignore them, it would lead to kind of wrong conclusions. So it's really important to consider all the context around the kind of campaign activity. And another thing is that, like, you have to map the infrastructure, fully map the infrastructure associated with threat actor, because if you don't map the whole infrastructure, you would miss some of the part of activity, and it would lead at wrong like tracking and attribution. And as I said again, contextual data are really important, and you have to consider all the geopolitical information and motivations behind the activities of the threat actors. And before I conclude my talk, I want to highlight some of the references I used for my examples. Not all the examples are mine here. So these are excellent resources created by outstanding researchers, and I highly recommend checking them. If you look at my paper, you would get the full list of references. And that's the end of my presentation. I would be happy to answer any questions if you have.